First, welcome. Good to see everyone here. I am very curious on what schools you are from. So I know a couple of you I talked to with biochemistry, right? Accounting and civics. You guys are in engineering. What about you?
Engineering.
What kind?
Aerospace.
Okay.
Film.
Film.
Chemistry.
Okay.
Computer.
Computer engineering. Okay. So, and then day one of going to college, and my college is very similar to UT Austin here. Some of the brightest students, highly ranked college, and instantly I became an atheist. You know, and the reason I became an atheist is I was in an engineering school, so everybody around me was an engineer, and I was studying to be an engineer. And we were super analytical, and the world I came from of religion and the world of science and math and calculus and thermodynamics simply didn't seem to match, right? So this makes no sense. Right? So for 10 years I was an atheist, enough to get 2 PhDs in atheism, right? And it was when I was 27 years old, after spending 5 years going through many of these arguments I'm going to show here, struggling with them, I decided to become a Christian. Okay. And now if somebody had told me from a religious background that you should not ask questions, right, I would have walked out. Because if I'm not allowed to ask questions, I don't think I can find answers, right? And sometimes as Christians we do this as well, is we shut ourselves to questions because I'm not sure what the answer is. But I think we're much better off chasing answers. It's also a very scientific way, I think. So I ran into, anyone knows what GTOR is? What is it?
General theory of relativity.
Yeah. Einstein's general theory of relativity. So I tell you the story of in 1915 or so, Einstein came up with his general theory of relativity. And it had to do with gravity. And we all think we understand gravity, right? So if somebody can tell me, what do you think gravity is? You don't need perfect answers, just any answer. What is gravity?
Force that brings things closer to the Earth. I don't know.
Okay, that's fine. It's a force between two masses,
Yeah.
right? That's how we typically learn, right? Einstein thought of gravity very differently. He thought of gravity in this sense. He said masses, especially large masses, like think of the sun, curve space. Okay, and how much it curves space, right? That's how he thought of as gravity. So he said masses tell space how to curve, and space tells masses how to move. I'll give you an example. Think of a trampoline, right? If I put a bowling ball on it, what happens? It's going to sink, so it's going to curve that space, right? Now if I put a ping pong ball on this trampoline, which already has a bowling ball on it, what happens? It's going to go along the curve created by the bowling ball, right? This is how Einstein thought about gravity. Well, why does that matter? What's that got to do with anything? The thing was that Einstein saw that his equations were predicting probably an expanding universe. And he did what all good scientists do when their theories telling them something besides what they believe. He fudged his equations. Okay. Later on, about 15 years later, he said it was the biggest mistake of his scientific career, right? But at that point in time, he fudged his equations. But obviously, the point of science is you release it for other people to take a look at it, right, and critique it. Other people critiqued it. Amongst them was a Belgian priest who was an MIT in physics, MIT PhD in physics, named Lemaitre. And Lemaitre calculated the equations and said, actually, you're predicting an expanding universe. Einstein resisted it for a long time because he saw what that actually meant. Okay, and it wasn't till the 1930 maybe he met up with Hubble, named Hubble telescope, right? And Hubble showed him that all the galaxies, all of them had a red shift. And when he saw it for himself, he said, yeah, my theory predicted an expanding universe. Why is that? Because what does a red shift mean? It means something going away from you, right? If you hear a car coming towards you, you hear a certain frequency of noise, right? If it goes away from you, it's a different frequency of noise. Same thing with light. So when something's moving away from you, things shift red. And so every galaxy you're showing a red shift. So, so Einstein also came to the conclusion that yeah, his theory was predicting an expanding universe. Why he didn't like it to begin with, and a lot of people didn't like it, is because if today the universe is bigger than yesterday, right? Then 10 years ago it was smaller. You go back long enough in time, what happens? It's a singularity, right? Infinite radius of curvature, infinite forces, right? But infinity is just an abstract concept, right? So it must mean everything started from a point. And as a joke, they call it the Big Bang, right? It was coined by somebody who didn't even believe in the Big Bang. Said, so you're telling us that there was a Big Bang. That was the joke. And this was a joke for 20 plus years. Okay, this was not like instantaneously things changed. And because of its theological implications, when you say something started and that something came from nothing, there was nothing before it, now you have to explain how did things come about, right? And this is something that they struggled with, the theological implications of saying that everything started from a Big Bang. Now the Big Bang was not just a company, they're not a fireworks, it was a highly choreographed event. Anybody has heard the term entropy? Yeah, what is entropy?
A measure of disorder.
Measure of disorder or chaos, right? So all systems move in the direction of what? Increasing entropy. You never decrease entropy, right? And so for some reason, the entropy of the initial universe was super low, meaning it was super organized, right? Have you ever bought something like, let's say, a coil of rope and put it in the garage, right? You come back a year later, it's all intertwined and tangled up and so on, right? Have you ever taken a tangled up rope and put it in your garage and a year later it's all smooth? It doesn't happen, right? Because entropy only works one way, right? And so the entropy of the initial universe, it was super organized. It surprised everyone, and between the Big Bang, right? The Big Bang created, I'll stay with the simple physics because, to be honest, I only understand the simple physics. Okay. There's the electrons, neutrons, protons, right? There's probably other stuff, but we'll stay at this level, right? The protons are super stable. The neutrons are not. But for them to get in within the first nucleus, when the Big Bang started, it had exactly 878 seconds. So less than 15 minutes. In that 15 minutes, the first nucleus had to form because the neutron otherwise has a very fast decay time. Okay. So it's like, wow, that's not a long time. Once the universe starts, you got 15 seconds. You know how long it took to create the first, we think of electrons as being in orbitals around the nucleus, right? Or in quantum mechanics, partial differential, they have these functions and so on. But for the first atom to be formed, because the energy was so high, it took 380,000 years. So the first 380,000 years of the universe, you had a nucleus with protons and neutrons, but the electrons were not revolving around the nucleus. The energy levels are so high, there's a sea of electrons just floating around. And so it was so organized, and the slightest thing, if it was the slightest bit off, the universe would have collapsed back. And so I was looking at that and saying, what is the reason for the Big Bang? Why was there a Big Bang, right? So I'll propose to you something super organized, and you tell me that if you see what is behind it. If you see a book, right? What do you think is behind the book? An author, right? Someone with intelligence, right? Now we can say it's the paper manufacturer and the print and so on, but that doesn't explain the book. What about a work of art? An artist. It's a given, right? Can you have a book without an author? I mean, maybe a wrong question to ask in the age of ChatGPT, but right? But even that is working off a knowledge base which came from humans, right? Can you have a work of art like that one over there without an artist, right? And that is the conclusion I came to, is we could not have had this highly organized creation of the universe without an author behind it. So the funny thing about it, actually I think I'll go back to that in the future, but I'll keep moving on here. Okay. So what is design? So I'm going to talk about inferring from design. So what is design? It's something complex, would you agree? Okay. Something specific. I mean, things could be complex. If you look at this thing on the side here, okay. Did you say this is design? Right? It looks complex, right? Looks like it does something, but to be designed, it should actually do something, right? It should be functional, right? So this here is a design of a car, right? But I want to point out a couple of things about the design. It's not enough that you have different parts which work, but the parts have to be machined to perfection. Like if you have 4 tires and all 4 tires are a different size, is a car going to work? No. So all 4 tires have to be the same size, right? And so that is part of the nature of design. It's not even just about getting the right parts. It's not even about joining the right parts together, but each part should be proportionally sized to every other part over there for it to function, right? It's a concept often lost in design, I think. Okay. How do designers think? Let's study some intelligent agents, right? I think I had with foresight, saying I'm trying to accomplish a goal, that this car should actually drive, right? Maybe it should drive 70 miles an hour at a minimum, right? You choose from competing possibilities, you optimize constraints, right? Can make a heavier car, so if there's a crash that I never get hurt, but it's going to cost a lot more in fuel usage, right? So optimizing between constraints. Generate large amounts of information rapidly, and to create irreducibly complex systems. Would you say a car is irreducibly complex? Right? You can remove some things and it'll probably still function, but at some point, if you remove a piece, everything stops working, right? And there's going to be thousands of pieces you will need before the car functions at any level, right? Okay. So let's talk about the DNA. This is the second one. I looked at the cosmos and that side of it, and I said, I think I see design in here. I see a mind behind this design. But what about DNA? Bill Gates said it's eerily like software code, right? It's got a 4-letter alphabet versus 26 letters. Anyone remembers the 4 letters?
A, G, T, C,
Right? A, G, T, and C, right? And with those 4 letters, you have semantic information. And what that means is that you can create a protein which is functional. Next time you have some protein powder, think about that, right? The knowledge that went into creating this protein, right? The odds of creating one protein by mistake, average length protein with 150 to 200 amino acids in 1 in 10 power 77. Now it's very hard to gauge big numbers. What does that even mean? The number of known elemental particles in the Milky Way galaxy is 10 power 65. Okay? Odds of making one protein by mistake, meaning it's functional, right? If proteins are not functional, they collapse. They have to, twist and turn correctly and fold correctly. Fold is the right word. They fold correctly and so on, right? Correct? But have you done proteins biochemistry? Right? They have to fold correctly, tertiary structure of proteins and so on. So the odds of getting one by mistake is 1 in 10 power 77. So you don't even have enough elemental particles. This is for one protein in one of our cells, right? So what information does it create? It creates this information in the DNA. It could be a random chance, super low chance, or it could be a mind. Because once you have a mind, it's not hard, right? What are the odds of writing a book by mistake? close to zero. But once you have a mind, it's not, right? Would you say this is designed or random? I'll give you a comparison. Right? Why is this designed?
That's information.
It's information,
Communicating
Communicate the message.
it's communicating a message, it's arranged in a certain way, it means something to someone, right? It fits in here, so somebody's got to figure out the right font sizes for that to fit in. The color matches, right? So you can say, we can see this is information, this is not obvious as information, right? So DNA is like this. It's got information in there, except a lot more information, right? So when I looked at that, I struggled to say, how do we get, my background is in the software industry. It's been a long time since I wrote code, but I'm going to show you a piece of code I wrote 2 days ago. This was me and Cursor together, okay? Now, can anyone tell me what this code is doing? It's summing up two numbers. That's all it's doing, right? Sum equals A plus B. It works. I tested it out, right? What does it take to start with a code which exists and make more complex code by random chance? Close to zero, right? There's a few things you could do. A plus B could become A minus B, right? Or A times B, or A divided by B, right? But notice this is not random. Everything happens in this one spot. If I randomly put characters elsewhere, I break the code. I don't make better code. I don't even make worse code. I have code which is broken. At this point, it's dysfunctional, right? And this is the challenge with the DNA. Even if you had somehow a starting point which is functional, but if you made random changes, you're going to break the code. Have you written code? You're a computer engineer, right? Have you written code? Yeah. Have you ever randomly made a change and the code became better? But have you broken the code because you typed in something by mistake? Yeah. So it's easy to break code. Anybody who writes code knows it's super easy to break code. But getting code to work, that's the hard part, right? So how do you do it randomly? What if I want to go from this existing functional code to a full-blown operating system? Can I go? I don't think so, right? Because the information needed for the rest of the operating system is so different from what I have here, let alone the fact that it has to happen randomly. But what if there's a mind behind it? Can you go from code to an operating system? We know that because we have a Windows operating system. We have iOS, right? There's lots of different, not one mind, but lots of different minds who collaborated together to get there. Right? So I think a mind is a better explanation for design than random chance. I'll talk about a third one, which is our planet, right? Does our planet show design, right? So interestingly, the sunlight which comes through the atmosphere happens to be the one we can see, right? Also happens to be the one that can be used for energy in photosynthesis. But there's part of the light which doesn't come through, the gamma rays and the X-rays, those happen to be harmful to us, right? How is that possible, right? That the ones we can use comes through, the ones which will hurt us doesn't come through. This is not even biological adaptation. This is the atmosphere is not letting through gamma rays and X-rays, right? Couple of other things. Oxygen percentage is 21%, right? If it was a little bit higher, then any fire we make would wipe out 2/3 of the US because oxygen is so reactive. If it is any less oxygen, then we can't make big fires at all. Could make small fires, but now you couldn't make bronze, copper, all the things for science and technology, all the energy that you need, you can't get up to those temperatures if oxygen wasn't more reactive. or at a higher percentage, right? It happens to be beautifully balanced with this 21%, where you're neither dealing with wiping everything out with fire, nor dealing with saying I don't even have any fire. Okay? So this is optimizing parameters, right? About relative sizes of stuff, sun and moon. 400 times farther to the sun from the earth as compared to the moon, 400 times bigger. And this had the biggest impact on the earlier story I was telling you about the general theory of relativity. Because what happened was the general theory of relativity, remember I said it shows that big spaces, big masses curve space. So they're looking at a couple of stars which are behind the sun. But when you're looking at something behind the sun, you don't see anything because the sun is so bright. But when the moon eclipsed the sun, and with this perfect size and distance, it eclipsed it completely, they could see two stars which were behind the sun. And that proved the general theory of relativity. That was some of the first empirical proof of the general theory of relativity. So somehow it seems to be built for us to observe things. Our world seems to be built for science, for us to learn things. Right? Location-wise, where Earth is, if we were any farther, we have a problem with freezing of water. If we were any closer, we have a problem with the evaporation of water. Right? It happens to be in this very narrow space away from the sun. And also the size of the sun. If the sun's size is any smaller, to get the same amount of energy and sunlight for the temperatures we need to survive, we'd have to be closer to the sun. Problem with being closer to the sun is the closer you are to a big mass like that, you could have tidal lock, which means the same side faces the sun the whole time, and there is no revolution, this rotation on the axis. Right? That's what happened to Venus. But if it's farther, then it needs a lot more energy coming out of the sun. It needs to burn a lot more fuel. And most stars, virtually every other star, has this huge ups and downs of energy which come out of the stars. Our sun is remarkably consistent how much energy comes out. What is that? So what I was faced with after 5 years of working my way through this is to say, surely there's a mind behind this, and this is a better explanation than that things happen randomly. Right? But what is a mind? Anyone wants to take a shot at that? Easy question. What is a mind?
It's related to the brain, but it's not the brain, it's immaterial.
Okay. Good answer. Anyone else? Is it different from the brain?
It's this.
So the brain, and I'm going to talk about a scientist named Penfield, Wilder Penfield. And what Penfield did in the 1960s and so on is, I don't know if you know this, but actually the brain doesn't have any nerve cells. So if you touch the brain, you're not going to feel anything. Okay. So if you actually cut somebody's head open, which will be painful of course, but could be done under local anesthesia, then you can touch different parts of the brain and see what does it do, right? And Penfield mapped every part of the brain, okay, and found that there were 4 things that happen in the brain. There's memory, there's emotions, there's movement, so he could touch a part and somebody's hand would move, right? And there was sensation, right? So they could feel something on there and so on, okay? But there are things he didn't find. Nowhere did he find abstract thought. Nowhere could he see somebody who was doing calculus, right? Or writing poetry. No map. Nowhere was the will. Even when he moved people's hand, he would ask them to say, did I move your hand or did you move the hand yourself? And they would always say the right thing. You moved my hand. Or if they choose to move their hand, I moved my hand. So they were able to tell the difference between what was happening in the brain, and so there seemed to be something besides the brain. Right? In fact, he studied people who had epilepsy, and he said, they'd have different sensations, they would forget things, so all things related to the brain. But he said nobody with epilepsy solved a differential equation. They simply did not do abstract mathematics during epilepsy. Why is that? Okay, so maybe those things are not in the brain, right? But design requires precisely that. We want both will, I want to design a car, let's say, and the abstract thought, right? How am I going to design this car? Put a blueprint together, etc., right? I'm going to introduce you. So if you've not read the book, The Immortal Mind, you should read this book by Michael Engner. Okay, I'm going to introduce you to this, and we'll use this to explore what a mind is. Okay, these are conjoined twins named Tatiana and Krista Hogan. Okay, but 75 to 80% of conjoined twins who get past the age of 2 are usually girls. Okay, for some reason, if it's boys, they don't survive. Okay. Okay, Tatiana and Krista Hogan. They share brain tissue. You can see that they're conjoined here. And here are some remarkable things about them. Tatiana controls 3 arms and a leg. Can see out of both of Krista's eyes. Krista controls 3 legs and an arm. Can see out of one of Tatiana's eyes. They're sharing a brain. This goes back to movement, sensation, right? They seem to be sharing all of this, right? Both can self-control their own limbs. They share a brain, but they don't share a mind. So one can study geometry and the other calculus, and then they simultaneously learn both things. Right? Does it make sense? Just pause here for a second. I know this is the.
So, how did they do that test? Did they divide them one on one side, one on the other, and then teach one calculus and then ask the other if they knew?
No, one is studying calculus, the other is studying geometry, right? But if one who's studying geometry doesn't understand calculus at all.
So they asked they taught one thing and didn't tell it to the other one.
Yeah.
Okay.
So if they were sharing a bunch of things, right, which are brain related, but they're not sharing the things which are mind related. And that's what I was trying to point out, that the mind is different from the brain in at least these 2 things, abstract thinking and will, right? So for example, one liked ketchup and could eat it all the time, the other hated ketchup. Right? So they had the will to choose, do I want ketchup, do I not want ketchup, right? So what can we infer from design? Behind every design there's a mind. Have you ever seen a design which doesn't have a mind? Now, we may not have thought about the mind. You look at an iPhone, right? You may not have thought about who created the iPhone, right? But whether or not we think of the designer, there is a designer behind the design. Yeah? Does that make sense? Okay. This mind is a personal mind. When I say personal, I mean chooses to design. The design doesn't come about by accident. The designer chooses to design, right? So when I went first verse of the Bible, Genesis 1:1, in the beginning God created the heavens and the earth, right? Is remarkable for its impact on physics because it says it's the coexistence of time, space, and matter, right? In the beginning, time, God created the heavens, space, and earth, matter. All 3 of them had to come together. Why do they have to come together? If there was no space, where would you put the matter? If there was no matter, what would you put in the space? If there was no matter and space, what actually happened in the beginning? Right? So all 3 of this had to come coexistence. Right? But this was consistent with what the general theory of relativity was saying. Right? So the mind behind it had to be immaterial, because the designer was before the design, immaterial. timeless, beyond time, and beyond space. Right? Some inferences we can make. Separate from the creator. Right? Mind needed to have that intelligence and all of that in place before things came into creation. Right? And here's the thing, I felt that mind was smart. Right? And I'll leave you with this. I think you may have one more slide after this. The designer gives purpose to the design. Do you agree with that? Who gives purpose to the iPhone? The designer, right? Who gives purpose to a car? Right? The designer. Wait, are you telling me the one who designed me had purpose for me? That to me was an eye opener. But until then, I never thought of myself as having a purpose or not having a purpose. I thought, okay, go to school, get an education, go work for somebody else, and work 40 years, and then you will retire. I didn't think of purpose in this whole journey. And for the first time, it struck me that my designer had a purpose for me. I didn't think too much about purpose because I was a little worried that if I dug into it, maybe I didn't have a purpose, and I didn't want to face that. But every time we see design, we see a designer who had a purpose for that design. Why would I be the one exception, right? And that made a huge, it may not matter to you. For me, it mattered a lot to say, oh, the designer has a purpose for me, specifically me. I don't mean a general us, I mean for me, you know. Okay, I'll summarize. Talk about three things. Our universe had a beginning via a control process. DNA has semantic information which creates functional proteins. A planet is optimized for light, transparency, oxygen, location, and size. Right? There's 10 other things. Where did consciousness come from? Where did my moral values come from? I think you have a talk in a couple of weeks where you're talking about moral values, right? The origin of our moral values and so on. My inference was all of this required a designer who's an immaterial mind, also known as God. Anyone knows what CTA means? Call to action.
No.
I have background in sales. You never finish a presentation without asking people to do something. So here's a call to action. Consider the evidence for yourself. Is it persuasive? You have to decide that. Is it persuasive, right? It took me 5 years to decide that. And I found it very persuasive. Consider alternate explanations for all of these, origin of the universe, information in the cell, and so on, right? Whatever your background is in. Consider, I mean, if your expertise is in information in the cell, consider alternative explanations. Until you hit any theory with counter ideas, you don't know how strong or weak the theory is, right? So it's always a good idea to look at what other way might this have happened. And from now on, whenever you see design, I hope you'll see the designer behind the design, right? Because I think it'll encourage you to say there's a designer behind this. Okay, I think I'm done. Let's see. I am. I don't know how I did on that. Put my phone down. Are we on time? I didn't make it.
Yeah, we're gonna get 6, so, if anyone needs to take off, yeah, but, any questions for Ganesh?
You mentioned about after the Big Bang, there were only 878 seconds for atoms to form. Is that
For a nucleus to form where the neutron and the proton would get together.
is that just saying the first nucleus or like all
No,
nuclei?
all the neutrons which were out there, neutrons have such a short half-life period and they disintegrate so quickly that they need to be paired with a proton within about 15 minutes. So any neutrons which have survived those first 15 minutes got into a nucleus within those first 15 minutes. everything else got, I don't know, matter, antimatter, got into some more physical particles, and I don't know enough about physics to go into the details.
What was appealing about atheism to you when you first got to college?
Can you say that again?
What was appealing about atheism to you?
It sounded intellectual. Everybody around me was sharp, smart, and they were all atheists. To be honest, I was part of a social tribe, right? And I took on the values of the tribe. This is how most people think, by the way. I want to see who's around me, whatever values they have, I automatically pick up, right? And so actually, was some advice I got very early in my career was to say, check your 5 best friends. Whatever income they have, odds are you're the average of their incomes, right? But that's true of any value that you pick, right? We do tend to take on the values of the tribe that we are with, right? It's always a good idea to question the values of the tribe we are with. And I say that even as a Christian, even at a church, question it, because you'll be stronger for having questioned it, and make sure you understand why you believe something, or you'll find out it was the wrong thing to believe and change your mind. But it sounded intellectual. The professors I knew at that time, many of them were atheists, certainly all the students were atheists. So from that perspective, at that point in time, I found it very interesting. It was not till a few years later I started the same questions I was asking of Christianity, I started asking of atheism. And I felt that it struggled to answer the questions. So as an example, the one question people ask all the time, and it's a very legitimate question, is if there's a God, why is there evil? Right? Well, okay. Assume there is no God. Right? Why is there evil? Right. And as I looked at most atheist philosophers, they eventually came to the conclusion there is no such thing as good or evil. Right? Then why pose the question about evil to God then if you're convinced there is no such thing as evil? Right? So and I also felt that atheism didn't give me any purpose. Right? So there's a lot of them. But any questions you can ask. To be honest, there are whatever questions people have, they should ask of all worldviews. I had since I grew up in a Hindu family, I was able to ask it of Hinduism. I certainly asked it of atheism. I asked it of Christianity. I spent a year looking at Buddhism. I asked it of Buddhism. But there's at least 4 questions which are you should ask of any worldview. There could be 100 questions, it's up to you, but I think there are at least four questions to ask. And there's the question of origin, where do things come from, right? Question of meaning, what gives life meaning? Question of morality, right? Good and evil, where does it come from, who defines it? And question of destiny, what happens after that, right? But you could add on more, whatever question you have. Yeah.
What would you say if, again, this is not my position, but if an atheist were to ask you, isn't the mind just the interworking of all the neurons collectively in your brain, making sense of how they perceive the world? So, according to the materialists, the mind is simply how the neurons connect and work with each other. Right. So how do we as Christians answer that?
So actually, if you go to read the book The Immortal Mind, Michael Egner talks about it specifically, and he says as a neuroscientist, he had many cases of people that he would do brain surgery on, or he would take photos of, and he shows some photos in his book, and where he said there is actually no brain. There's only water. There isn't even a brain here, right? And then this person has not only done well in elementary school, middle school, high school, even got a master's degree. So it's like, there isn't even an interworking of brain neurons to work with, because there isn't anything. So again, I can't do justice to the book. But I do think a good starting point will be to say it's something we can connect on with an atheist, right? Which is to say we both agree that we should be logical, right? And if we think that the brain and all the workings of the brain simply came from random changes over the last 4 billion years, why do you trust that thinking to be logical?
And the common response you get is like, what if the multiverse is true? And
Oh, yeah.
so, how would you respond to that?
One, I'd like to approach it from a science perspective, right? Which means I like to see evidence. And one thing with multiverse is there is not any evidence, right? My opinion is that the only reason people throw up the multiverse is because the universe seems designed and fine-tuned for life. The number of parameters which have to be so accurate for things to work is that how did these things become so accurate? And so, for example, there's we were talking about Steve Weinberg earlier, and there is a parameter called the cosmological constant, which is part of this Big Bang theory, and this factor has to be fine-tuned to 1 in 10 power 123, right? That's less than the number of elemental particles in the universe. Okay? And so how is it that precise, right? To get around this problem, say if there are enough universes, in one of these universes you get the right constants, right? The problem is to say, people are making an assumption, one, that we are able to change gravity, we are able to change cosmological constants. These physical constants were actually being able to change from between universes. How do we know that's the case? No one knows how these can be changed, right? Secondly, they're taking the design problem only one step further. Okay, so I'll give you an example. Think of like a washing machine, right? Bubbles coming out of your laundry machine, right? And each of one is a universe. This is their view of it, right? So there's a universe generating machine which is changing parameters around, and boom, one of them actually works. But what is the origin of this universe generating machine? This itself has design in it because it has to change the right parameters, right? Where does this machine come from? So we're just pushing the design argument one step further. I think it's very popular it's popular in popular science, popular psychology. Very unpopular amongst physicists. No one serious talks about multiverses.
You talked about Einstein fudging the numbers of the cosmological constant and whatnot. If, to my awareness, like the typical statement of the general theory of relativity, or the field equations, still have the cosmological constant in
It's a great
there.
question.
So,
Yeah.
you know, what exactly did Einstein do?
So Einstein fudged the cosmological constant to keep the universe static. And they removed it later on, but many decades later, in the 1990s, they reintroduced the cosmological constant for some totally different reason. They just called it the same thing.
They called it what, cosmological blunder or something?
Yeah, cosmological blunder, I mean, he's a great scientist, but doesn't matter, great scientist or not great scientist, anyone can make mistakes, right? It's the ability to recognize it at some point and say, yeah, okay, I'm willing to admit I made a mistake. Part of what drove him, by the way, was the fact that at that point in time, Nazism was coming in and they hated the Jewish scientists. And so because of that, and because Big Bang was pointing to a God, as the origin, Einstein eventually left Germany, moved to Belgium, moved to, I think, New Jersey maybe, Princeton or wherever he went to, right? But he was forced out of those places. And so were a whole bunch of Jewish scientists, just because the Nazis didn't like that. They only wanted material things. They did not want anything immaterial. So where politics intersects with science. Always a bad idea in my opinion, but yeah. That's what drove him out. And then somewhere along the way, he said multiple things, like God doesn't play dice, and none of which made him popular with Nazis, you know. That's why I think part of science of always, and even religion always, has to be ability to ask questions and understand why are we doing what we're doing, right? If I don't understand it, is there any reason for this?
Well, thank you so much.
Thank you. Thanks for having me.
Okay.